Have you ever wondered about quantum mechanics, lasers, or the properties of waves? I know that I was definitely curious about these things back when I first started my quest. Along the way, I've learned a bit about quantum mechanics and some of its basic applications. The treatment of this material was mostly qualitative. I tried to avoid the complex math for now and wanted a more experimental visual representation of physical phenomena. Back when I first started, I read some of the Feynman lectures, specifically Volume 3. However, my knowledge of waves, mechanics, and electricity and magnetism was only around the introductory level. So I decided to begin to explore some basic lab experiments in order to gain a first exposure to some elementary concepts. One of my mentors, Dr. Madejski, suggested that I replicate a lab experiment that demonstrated the interesting diffraction patterns of light through small slits on CDs. I eventually found a lab from MIT OpenCourseware that demonstrated this very concept from the 802X class for electricity, magnetism, and modern physics. I did every experiment in the lab using my own materials and some from the iLab. I was even able to see that instead of light simply shining through two slits, the light particles or photons were scattered, forming a nice distribution on a panel. I was also able to determine the distance between tracks on a CD, using the wave model of light. During that day, I felt that I had learned more than I did reading the textbook, because I had experienced the physical phenomena firsthand. The biggest project I attempted to create was my own interferometer. This was an experiment that I was set on from the beginning. I knew that I wanted to create one because I had read about their significance in proving gravitational waves and attempting to determine the speed of light over 100 years ago. I knew that if I created an interferometer at home, it wouldn't be nearly as impressive or accurate as a store-bought one, but I still wanted to try and see if I could get some interesting results. My goal wasn't exactly to conduct a clear experiment, but rather to make something impressive and discover the concepts for myself. Using foam board, a beam splitter cube, dollar store mirrors, $20 laser pointers, and a magnifying glass, I was able to create something that looked pretty cool. Although I couldn't exactly see a definite interference pattern, I definitely noticed some overlap when I used the magnifying glass to examine my results. I was so proud of what I created that I made a trifold detailing the process of the experiment, which is right here. I plan to demo this at Expo, but now you can just see it from afar. Although I wish I could have learned more about the math behind quantum mechanics, as well as some more advanced topics such as the Schrödinger equation, spin, and the quantum mechanics of molecules and atoms, I hope to explore this during a summer project and begin to create some interesting computer simulations of various physical phenomena for my next quest. So, thank you for watching.